Alright, y'all, let's work through this problem. This is a launch angle problem. I apologize for being less than engaging. I don't feel particularly well when I'm making this example. So, first thing we want to do when we're solving any of these problems is we want to draw a diagram of what we have going on. So when I'm looking at this one, we got a Daredevil launched out of a cannon, 35-degree angle, velocity 17.5 meters per second. So here's my cannon. Okay, here's the Daredevil. Okay, he's going to travel some curved path like this. Okay, and let's just assume start and end in the same place. Obviously, it's not exactly how it would be, but that's what we're going to go ahead and assume for this problem. So we know that the angle he's launched at, 35 degrees. We know that the velocity he has to start with, 17.5 meters per second. So just like we've done, we're going to make our X and our Y chart. But there's a couple of things that are going to be different. So just like before, we're going to try to put our numbers in that we're given. But in this case, those two numbers are 17.5, which is forward and up, and 35, which is forward and up. That means we can't put it in the X or the Y, because if the direction is both out and up, we're not able to use that. So we have to find a way to combine those together. So the only number that I know for sure is that in the Y direction, the acceleration is negative 9.8. So I used positive on the last example, so let me explain why this one's negative. Remember, what we've been doing is forward is always the positive direction, so in the X direction, positive is to the right, but in the vertical direction, positive is up, because it's launched up to start with. So that means down, gravity, which is always down, would be the negative direction. So it's something we have to be careful of here. Other than that, there's not anything else I can do, so I'm going to go to B. Find the X and Y components of the Daredevil's initial velocity. So here is the Daredevil's initial velocity, 17.5. It's at an angle of 35 degrees. And we know that that motion is partly forward and partly up. Okay, so we're trying to find the X value, which is A, and the Y value, which is B. Okay, so if I look at my equations, that's going to be these down here, solving A, solving B. And these you just need to plug into your calculator. Be careful of how you put them in, but you're just going to plug the numbers in. So the first one I'm going to do is A equals C cosine theta. So when I plug that in, C is 17.5, and then cosine of 35. You'll need to be careful of how you put it in your calculator, but basically most of calculators, you just put it in the way they look. So 17.5 times, here's my cosine button. It's not the negative cosine, just like we did the negative tan. It's not like that one. And then here's the angle, 35. So there's my first value, 14.3. And that is the forward motion. So that goes here. That's the X velocity. And then we're going to solve B. Plug the numbers in. This one is C sine theta, which when we plug it in is 17.5 sine of 35. Excuse me. Okay, so I'm going to change the cosine to sine. Everything else stays the same. And I get 10.0. Okay, that is your y velocity at the beginning. Now be careful, on the last problem we said the initial y velocity is 0 because it went straight forward and it wasn't going up and down to start with. This one is different. It is going up and down to start with, up in this case. So the initial velocity would be that 10 value. Okay, so that takes care of B. Okay, so C, what is the max height she will reach? So we're looking for how high is she going to end up at the highest position. Okay, so that's solving for D in the y direction. So we're going to use one of our old faithful big chalupa ain't got no times because that's my y direction. The problem is I only have two things right now, and I need a third one if I'm going to solve for dy. So the two things that are left are time and final velocity. Time is not something we can assume, but the final velocity is. And the reason is, and hopefully you're guessing it's 0, the reason is at the highest point it's not going up anymore, but it hasn't started falling yet. So that means your final velocity in the up and down direction would be 0. So v final, v initial, a and dy, that's going to be ain't got no time. Okay, so when we plug that in, we get D equals, we get VF squared equals VI squared plus 2 times A, and here's where the negative matters a lot, D. So 0 squared is obviously 0, 10 squared is 100, 2 times negative 9.8 is negative 19.6, and D hangs along for the ride. I need to get the 100 to the other side because it's being part of the 19.6 but it doesn't have D, so I'm going to subtract the 100 to both sides. Okay, gives me negative 100 equals negative 19.6D. Opposite of multiplying by negative 19.6 is to divide by negative 19.6. That's going to get rid of the negatives, and that's going to give me a value of D of 5.1 meters. Okay, D, how long will it take her to reach the max height? So that is looking for time. Just like we've done, time goes in both the x and the y direction. Since I know everything else about the y direction, I'm going to use the y equations, and I'm going to use specifically Old Faithful to do that. So you can use ain't got no time, but your Old Faithful is going to be the easiest from a mathematical standpoint. Okay, so VF equals VI. Can use the y direction plus A T. Again, we're trying to get the T by itself, so we got to subtract that 10 over. Negative 10 equals negative 9.8 T. We're multiplying by the negative 9.8, so we're going to divide by it. And we get T equals 1.0. We'll go ahead and round a little bit more on this one, do 1.02. Okay, now be careful. This is the time to get to the max height. Okay, E wants to know what's the total displacement they travel before hitting the ground. So total displacement is this value from the cannon to the point that they reach on the other side. How far is that? Okay, so this is an x direction thing. The x direction equation is v equals d over t. Okay, so the v we need to use is the x velocity, 14.3. The d I'm solving for is the x displacement, so that's going to be this one. But remember that the time I need is the total time. Well, I have the time to get to the max height, which is half of the time. So the value I'm going to use for time is 2.04. Now, some of you would just solve this and then double your final answer. That's fine. If you need to do that, just be careful that you're doubling at some point. Okay, so you're going to multiply the 2.04. I said it and then I didn't write it. My apologies. And I'm going to multiply that to both sides. And when I do that, I get a displacement value of 29.2 meters. Okay, that should help you get done with the practice. If you have any questions, make sure to send me a message or talk to me next class, and we'll make sure to help take care of it and get it addressed for you. Have a blessed day.